Welcome to K-Tech High School and Junior College. The sun is up. The sky is blue. Today is beautiful and so are you. Wishing you a day full of sunny smile and happy thoughts. Good morning to everyone. Children, as you all know, we have started with our lesson number 4, current, electricity and magnetism. So children, in today's session, we will be learning about magnetic effect of electric current. We have studied about two types of magnets. Those are permanent magnet and temporary magnet. Do you remember them? Yes. This is how one can define them in simple words. Permanent magnet retain their magnetism for a very long time, and temporary magnet retain their magnetism only for a short period of time or until kept under an external magnetic field. We will talk about temporary magnets first. Temporary magnets retain their magnetism only for a short time or until kept under an external magnetic field. When removed from the external magnetic field, they lose their magnetism. Got it, children? Now, we have seen two easy processes used to make a temporary magnet. We use objects made up of ferromagnetic material such as iron nail or an iron bar. What do we know about magnet? Yes, we know that magnets attract magnetic objects like iron attracts or repel other magnets. Do you know what is this property is called? This property of magnet to attract or repel is called magnetism. Look at these examples we saw. What is happening here is that the two objects acquiring magnetism to their processes. So, these objects weren't magnets. They acquired magnetism. This process through which any non-magnetic object acquires the property of magnetism is called magnetization. Yes, magnetization. This can also be defined as the process to magnetize any non-magnetic object. So, in these processes, we are magnetizing the ferromagnetic object. Now, there is one more way in which we can magnetize these objects, and that is by understanding that electric current generates magnetic field. Now, first, let's enlighten ourselves about this. In 1819, there was a scientist named Hans Christian Ørsted. He found out that if you keep a compass near a current carrying wire, then the compass needle deflects to some extent. Yes, understand these words. When current passes through this wire and we keep this compass near the wire, the needle will deflect. This will not work if the current in the wire is feeble. However, in that case, if we remove some part of insulated coating and keep the compass in that region, you will see the deflection. Now, we know that the fact that if we keep this compass at rest away from any other magnet, then it will align itself in the direction of Earth's magnetic field. That is, the red part will point the north direction while the other part will point south direction. What will happen if we bring any magnet near this compass? Well, if we bring the north pole of the bar magnet near the red needle, the needle will show deflection. The needle now align itself to the direction of the magnetic field of this bar magnet. We know that in a bar magnet, the field line emerges from the north pole curve around the magnet and ends at the south pole. So if we move the compass in the direction of the magnetic field, then its needle will also align itself in the direction of the field. Keeping this knowledge in mind, let's go back to our copper wire. Here, the electric current in the wire produces magnetic field around the wire, or in other words, the wire becomes a temporary magnet. This is the reason that the compass needle deflects when brought near this wire. Understood, children? Let's learn electric bell. Children, we have just learned what electromagnet is. Any conductor, such as a straight wire through an electric current is flowing, is an electromagnet. That's because there is a magnetic field around it. However, we can make the magnet strong by wrapping the wire around a piece of iron, such as an iron nail. Even if the current is same in both the cases, this one will result in more stronger electromagnet field. Now there are some factors on which the strength of electromagnet depends. The current flowing in the wire is one of them. If we increase the flow of current in the wire, the strength of the magnetic field of this electromagnet will also increase. Is there any other way? Yes, there is. Another way to increase the strength of this magnetic field is by increasing the number of turns of the wire around the nail. More the number of turns, stronger the strength of magnetic field will be. Now children, we will see few applications of electromagnet. For where do we use that? You must have seen large machine used to lift up cars. They have an electromagnet in them. This electromagnet is so strong that it can lift the whole weight of the car. Electromagnets are also used to separate metal objects from a pile of junk. Now, what if I tell you that they are used in the fastest train around the world? Yes, the Shanghai Maglev train is counted as the world's fastest train, and it works on the concept of electromagnetism. Now, let us learn the use of electromagnet in a simple devices such as electric bell. Yes, most of the electric bell which we see nowadays is an electric bell. Here is a simple circuit diagram of an electric bell. This is the inner structure of the bell. Let me tell you first the names of the basic components. Now see children, this is the push switch, which is nothing but a switch we press when we ring the bell. This is the coil of wire wound around an iron piece. Remember, we just learned the simplistic version of the actual circuit. So, it is act as an electromagnet when an electric current flows through the circuit. Okay, now see children, this one is the battery. This is the striker which strikes the gong that when we hear the sound. So we can see that this is the circuit that can be formed. If not complete, why it is not complete? Well, we haven't pressed the switch here. When we push the button, the circuit gets completed and the current flows from the positive terminal to the negative terminal. But when the current flows through the coil, it becomes electromagnet. The electromagnet then attracts the soft iron towards it, and in the process the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original path, the circuit breaks. It no longer connects the wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing. That is the basic idea of an electric bell, how it works. I hope you all have understood this concept, children. So, now let us summarize what we have learned in today's session. What is magnetic field? When electric current is passed through a coil of insulated wire coiled around a soft iron bar, the iron bar behaves as a magnet. This is called magnetic effect of electric current. Magnetic effect disappears as current stops to flow. Applications of magnetic effect. Some of the applications of magnetic effects of electric current are electric bells, telephone, electric cranes, etc. What is an electric bell? An electric bell is a mechanical bell that functions by means of an electromagnet. When an electric current is applied, it produces a repetitive buzzing or clanging sound. Electric bells have been widely used at railroad crossings, in telephones, fire alarms, etc. Now let's take a look on the notes for today's topic. First, we will write the new words followed by the glossary, scientific meanings of the words. Question number 1, choose the correct option and fill in the blanks. Question number 2, define the following terms followed by question number 3, answer the following question. Question number 3 is continued here. The working of an electric cell, followed by question number 4, give reason. So you need to write all these notes. So children, we have finished with today's session. I hope you all have understood. Thank you, dear children. Take care.